Hi guys, this is Adarsh Pratap Singh. Welcome back to the channel. Today we guys will be discussing about a very popular machine learning algorithm, that is linear regression. So before starting, I would like to tell you guys that we'll be discussing the mathematical as well as the theoretical part of linear regression model, or you can say algorithm. In the next video, I'll be showing you how you can use that mathematical as well as theoretical knowledge and apply that with the help of Python and implement the algorithm. So like linear regression basically is used to find the best fit of a line between your data. So suppose you have some data. So what we do basically is that we find a relationship between the independent as well as dependent variable. I'll tell you what is independent variable and what is dependent variable. So basically, if we talk in a very short term, linear regression is the relationship between independent variable and dependent variable and the line, and we plot a line in the on the data, and we get to know the upcoming results. So suppose the linear regression model is basically used to uh, like predict continuous values, unlike classification models where we classify the data into some classes. In linear regression we predict a continuous value. Suppose you wanted to know that if you train a model on linear regression for weather prediction. You use your data, you predicted the weather, you use the data of Delhi, and you are now trying to predict what will be the weather on 24th March 2025. You give everything, give the required thing to the model, and it will predict a continuous value of what will be the temperature tomorrow, or whatever you guys have trained it for. So like moving ahead, will I'll tell you that we have basically two things. We have a x coordinate, or we have x and y coordinate. So suppose these are our data points, okay, and we use mathematical concept of a straight line. Like no, you see, linear regression is not only about straight line, it could be any other curve, but in this particular topic, linear regression means finding a linear relationship. Linear means a straight line. So when you find relationship between two straight line, you get a like generalized equation, that is y is equals to mx plus c. Here y is the dependent variable and x is the independent variable. Independent variable means that it is independent of everything, and this is the variable which you will be providing to the model. And this is the dependent variable. Why it is called dependent variable? It is called dependent variable because this dependent variable depends upon what data you are providing to the model. So it depends, it totally depends upon the independent variable, which is this independent variable. Please ignore my handwriting, it's a bit bad. And this c, some people call it like error, but in general mathematics we call this intercept. So if we extend this line to this part, this is what we call as our intercept, y intercept in a mathematical language, where your x axis tends to 0 or x axis is equals to 0. The point which you get on your y axis is known as your intercept. So this is the intercept. And yeah, so these are the points. Suppose these are your points, these are your data points, and this is the best fit line which you got through training your model. So suppose you ask for a new, like you gave your model this value, okay, so the model will try to predict based on the equation. This m this m is known as slope. We call this slope. And what is slope? Slope is basically, in mathematical term, if you say we we can say that say it like the tan theta. tan theta is basically the slope, or you can say the differential dy by dx of this equation will give us the slope. Okay, if you try to differentiate this, y is equals to mx plus c. So if we differentiate this with respect to x, we will get dy by dx is equals to d mx plus c with respect to x. We differentiate this, c's are constant, so this we get 0, and here m is a constant multiplied with the x, so we get m. So dy by dx is equals to m, which implies that this m is our slope, and this is a with this and this c. These two are very important parameters that our model will get, and based on these two parameters, like on m, the value of m, and on the value of c, we will be predicting our continuous value which our data set doesn't have. So this is our data, and yes, we have some different algorithms which we use to optimize our algorithm. We have gradient descent, we have more different algorithms which you can use, or you can surf it on internet also. Those are also mathematical part. If you want that, if you want me to tell you more about on these particular algorithms or the optimization algorithms, do let me know in the comment. I'll tell you about that also. And we have, and the error part, which not this c, but the error between the predicted error is a value. Error is nothing but just the difference between predicted value as well as the original value. So if we extend this line till here, and this is our predicted value, okay, and this is our original value which it should have, or you can say this is our original value. This let me mark it with another color. So let's take it again. Let's extend this line. Okay, this is our original value. This is our original value, and the marking on the line with white is our predicted value. So this distance is our error. We have we have many different ways to calculate this error. One of this is the mean square method, like squaring the square method, that is summation of the original value minus the predicted value from I equals to 0 to I equals to n divided by n. Like this is the mean squared error, which we denote with MSE. Like this is just a short form which I am using. It could be something else also, but yeah, I use this MSE, which is known as mean squared error, and you get the summation of this, and you square this also, my bad. And in this way you find the error, and you try to minimize this thing. Our optimization algorithms do works nothing but they just try to minimize the error, and minimizing the error will make our model more accurate, and more the accurate our model is, better the model it will become. So more the accuracy, better the model is. You guys might know, like it's just a basic common sense thing which regularly happens with us in our daily life also. Like the accurate a person is, more better that person is considered. So yeah, this is about the linear regression model. If I show you some algorithms here, wait just a minute, I'm trying to take into text mode. Let me show you something. Like yeah, these are the ways in which you can, like these are the generalized equation to find a and b. Here a is the intercept and b is the slope. So this is how you can find like summation of y multiplied by summation of x square minus summation of x and multiplied by summation of x into y divided by n. N is the number of iteration you guys will be following, number of iteration that is totally dependent upon your variable. So I'm sorry, not the variable, on the data. Like this is the number of data you have. Okay. And here also n means the same, summation of xy minus summation of x minus multiplied by summation of y divided by n summation of x square minus summation x ka whole square. So this is all about, I think you should, like everybody should know about linear regression. In next video we'll be covering the implementation part. So thanks for joining us. Thank you.